In this video, we'll be going over how to write implementation blocks when working with generic structures. When we implement functionality on generic structures, we have two options: generic implementations and concrete implementations. Generic implementations allow functionality to be added for any type that can be used with a generic structure. Concrete implementations allow functionality to be added to the specific type indicated as part of the implementation. Concrete implementations are still restricted by the types that can also be used with the generic structure. Let's set up a trait and some enums. Here we have a trait named game, and it has a function called name, which just returns the name of a game. We also have two enums, one for board games and one for video games. Both the board game and video game enum implement the game trait, as we can see here, and the video game one implements it here. The details of this implementation is hidden for this slide, but it just returns the name of the games. Next, we have a generic structure named playroom, which is generic over any data that implements the game trait. The field in the playroom structure is just named game, which is a type T that can be any type of game. Down here, we have an implementation block that implements some functionality for a concrete type. Specifically, we are implementing the playroom type only when it contains a board game. So this will be the generic type that's used in place of T, which also happens to be a game, since we know we've implemented game for board game. In this implementation block, we just have one function named cleanup, which just prints out a message to clean up the room after being done with the board game. On the right, we create a playroom that contains a video game and also a playroom that contains a board game. We have defined some functionality on playrooms, as we can see here. However, this functionality is only for board games. So when we call this line here to do a cleanup on the board game room, it'll work just fine. However, if we try to do a cleanup on the video game room, we'll end up getting an error. The compiler error that we get will look something like this. It indicates that the cleanup method was not found in the playroom that contains a video game. And that makes sense because, as we can see in the previous slide, we only implemented this cleanup function for playrooms that contain a board game. Now we will move on to implementing functionality on a generic structure that can be used with any type. The syntax for implementing functionality that is generic over any type is similar to the generic specification on the struct itself. Here we have the impl keyword, the generic specification here surrounded by angle braces. And as you can see, it's the same one that is up here for the structure itself. So we have the impl keyword, our generic information, the name of the structure, and then the generic types that this structure is going to utilize. Within the implementation block, we create a function named func in this case, and the function takes two arguments. One takes a generic t, and the other one takes the generic u. Note that using t and u as function parameters within the implementation block is optional. You can write functions that have any parameters that you need, and this is just to illustrate that you do not need to further specify the generics on the functions themselves. So you'll see that we're using generic t and u, but we don't have any generics specified here after the function. That's because we specified them after the implementation right here. We can also use the where clause on implementation blocks. Similar to the struct, the where clause comes just before the curly braces. So down here on this implementation block, we have our impl keyword, our t and u, and we have the name of the structure followed by the t and u. We then have the where keyword, and we specify the traits that are required for both the t and the u. This offers enhanced readability for generic types and their constraints. Here's an example of a generic implementation for our structure. First, we have the impl keyword, followed by the generic type t, the constraint for our generic type, which is the game trait. We then have the name of our structure, and then the name of our generic type. This generic type T is the one that's going to be used in the structure. The code here is telling us that we are implementing some functionality for the playroom structure, and the generic type T for the playroom structure is some type that implements the game trait. The function being implemented is simple and just prints out the name of the game using the trait function. So we have a print line, we get a reference to self, we access the game field, which is here, and then we then call the name function, which is defined as part of the game trait. To utilize this implementation, we are creating two playrooms. One has a video game, and the other has a board game. Since we have a generic implementation up here that's generic over any type of game, we can access the game info function for both the video game playroom and the board game playroom. When we run the code down here, we'll get the game info for the video game, and it'll print out that we have an Xbox. The second line, we'll get the game info, and it'll print out that we have a Monopoly game. If we wanted to, we can create another enum or structure, implement the game type, and then use it just like we've been using the video game and board game rooms. So all we need to do is just implement the game trait on any other type, and we can automatically use it within our playroom, and it will get the game info function. To recap, generic structures can have both concrete and generic implementation blocks. Concrete implementations only apply to the type indicated in the angle braces. Generic implementations apply to all types that also implement the indicated trait. There's two syntaxes available for generic implementation blocks. The first syntax is here at the top, and it just has all of the trait information and generic types in line. So we have a generic type T, and this generic type T requires trait 1 and trait 2 to be implemented. And we have a generic type U, which only requires a trait 3 to be implemented. We then have the name of the structure, the generic types for that structure, and we can also use the generic types T and U within this implementation block. However, that is optional. We also have implementation blocks using the where clause. And within the where clause, we have the T and U, and we specify the trait bounds on one line each. Again, we can optionally use the T and U as function parameters within the implementation block.